Good morning. In the previous video, we have discussed by considering the equation number 12. This is the equation number 12 I have written here. Then for first approximation, we have neglected the term containing gamma square. Then we have integrated the remaining part from 0 to a. So then after that, we have evaluated for m is equal to 0. For second integral becomes 0. Then we have obtained k is equal to k naught. And finally, we have obtained the expression for wave function z of x, that is equal to b naught into e to the power ikx into 1 minus gamma sigma cn minus k square minus kn square minus 2 pi inx by a. That was the equation number 17. So till equation number 17 we have discussed. Today we will continue our discussion. Once again, that means in this discussion we are considering both gamma and gamma square terms. So consider the equation number 12. This is the equation number 12. Just you refer your book. So for equation number 12, you multiply with e to the power minus ikx. So when you multiply, it becomes b naught into k naught square minus k square a. Then gamma into k naught square minus kn square bn plus b naught cn. Here you are getting e to the power I kn minus k. Kn minus k is nothing but this is minus 2 pi in by a, right? So substituted here. So it becomes, then you have to integrate from 0 to a plus second term gamma square. So sigma bn dash cn integration 0 to a e to the power, take the common terms outside, right? Now what happens here? In the e to the power ikx into e to the power minus ikx, it becomes e to the power 0. Remaining terms are e to the power I into minus 2 pi n by a minus 2 pi n dash by a of x. So taking the common terms outside, you are getting e to the power minus 2 pi I n plus n dash by a into x dx is equal to 0. This is the equation number 18. Now when you are considering to this, here already the first term is integrated here because b naught into k naught square k square e to the power ikx into e to the power minus ikx e to the power 0, that is 1. Integration of dx is x, upper limit is a. Therefore here you are getting this. Okay. So now you consider the first integral. As you know, it is a standard integral. So the first integral is 0 for all values of n. Therefore, there is no need to bother. Similarly, since n is an integer, n dash is also an integer. Therefore, n plus n dash is also an integer. Right? So therefore, you can say that e to the power minus 2 pi I n plus n dash by a x dx is equal to 0. That means second integrals also reduces to 0 except for one value. That is what? When n is equal to minus n dash, this term becomes e to the power 0, that is 1. So therefore, only for n minus n dash, n equal to minus n dash, the second integral retains. Therefore, its integration value dx, that is x, upper limit is a, lower limit is 0. So this is the term you are getting. Now a is common term, get cancelled. So the remaining term is b naught into k naught square minus k square in k square plus gamma square integration summation n dash not equal to 0 bn dash c minus n dash equal to 0. How you are getting this? See here, you have to substitute n is equal to minus n dash. N is replaced by minus n dash. Okay. So, since n is equal to minus n dash, two summation reduces to single summation sign. Okay. This is the equation number 19. Okay. Now, consider the equation number 5. So, equation number 5 gives the expression for f of x. F of x is equal to sigma n is equal to minus infinity to plus infinity cn e to the power minus 2 pi inx by a. So, here when you are considering to this, what happens? If you substitute n is equal to minus n, what happens to this equation? F of x is equal to sigma n is equal to minus infinity to plus infinity. N is equal to minus n. That means infinity to minus infinity, you can reverse it. C minus n e to the power 2 pi inx by a. That means this expression and this is one and the same. Just we have replaced n by minus n. So see, when you consider n is equal to minus n, it becomes cn. It becomes, when n is equal to minus n, this expression becomes e to the power minus 2 pi nx by a. Just a small change in this expression. In the other way we have written this equation. See, in the beginning of this class, we have mentioned that f of x is real. So, since f of x is real, if you take the complex conjugate of f of x, then what happens if I write f star of x is the complex conjugate of f of x? Since it is real, complex conjugate f star x is equal to f of x. So, see, this is, you can call as the equation number 20. So, therefore, what happens? This is equal to sigma n equal to minus infinity to plus infinity cn star, right, into its complex conjugate. Cn star is the complex conjugate of cn I am writing. It becomes plus 2 pi inx by a. So this is the equation number 21. If you compare, right, since f star of x is equal to f of x, when you compare equation number 20 and 21, what you are getting? C minus n is equal to cn star. So that is equation number 22, you can call. So now what happens here when you consider this from equation number 19, you have to consider. So what is the equation number 19? Equation number 19 gives the, just recall it now. Equation number 19, that is b naught into k naught square minus k square plus gamma square sigma n dash not equal to 0 bn dash c minus n dash is equal to 0. This is equation number 19. What happens here when you apply this condition? It becomes b naught k naught square minus k square plus gamma square, right, sigma. Now what you have to do is you have to write the expression for bn dash. So that means you know the expression for bm, right? Bm is nothing but B naught Cm divided by Km square minus K square. Use this expression. So what happens? It becomes B naught into Cn, since n dash is an integer, n is also an integer, therefore no need to put a dash here. So divided by Kn square minus K square. So now what happens here? C minus n dash, right? That becomes Cn star. That is Cn star you are getting. So this is equal to 0. So therefore what happens here? You are getting now K naught square minus K square plus gamma square sigma n not equal to 0 Cn star into Cn divided by Kn square minus K square is equal to 0. Now you rearrange the equation for K naught square. So K naught square is equal to, it comes to right hand side, it becomes K square. Now when it goes to right hand side, it becomes minus, take minus inside this bracket. So it becomes plus only K square sigma Cn star Cn divided by, so since I have taken negative sign inside here, it becomes K square minus Kn square. So this is equal to what? K square plus gamma square sigma Cn star Cn divided by K minus Kn square can be written as K minus 2 pi n by A whole square. So this is equation number 23. So now what you have to do is you have to simplify this. Now since we know that the energy E is equal to h cut square K naught square divided by 2m, or K naught square is equal to 2me divided by h cut square. Similarly, you recall the expression for Vn. In the beginning of the discussion, we have considered Vn is equal to minus h cut square gamma divided by 2m into Cn, or rearrange it for Cn, it becomes minus 2m divided by h cut square gamma into Vn. So now you consider the expression for K naught square from equation number 23. You multiply both sides of this equation by h cut square by 2m. Okay. So when you do this, h cut square K naught square divided by 2m is equal to h cut square K square by 2m plus gamma square h cut square by 2m sigma. So now what you have to do? You have to substitute for Cn star and Cn. Therefore use the same expression. Take the modulus of that. Okay. So therefore you are getting Vn square into 2m by h cut square gamma whole square divided by, sorry, here it is k square minus k minus 2 pi n by a whole square. Right. So now still you can simplify. What is this? This is nothing but the energy of the electron, right? That is, I can write E is equal to h cut square k square divided by 2m plus, now you can simplify. See, gamma square get cancelled. One h cut square is here. Then the remaining term is modulus of Vn square. Sigma is there, right? Divided by, what else remains? Here it becomes, see, 2m get cancelled. So 1 2m remains in the numerator. You bring to the denominator. Then what happens? This h cut square is here. This 2m you have to bring here. H cut square by 2m. So then you multiply inside the bracket. Then what happens? H cut square k square minus h cut square by 2m. H cut square by 2m into k minus 2 pi n by a whole square. So this is the equation number 24. Okay. Now let us we consider, see, suppose if k square is equal to kn square, right, approximately equal to kn square, what happens? See, then k is equal to plus or minus kn. So that means what? Plus or minus kn is nothing but k minus 2 pi n by a. That is plus or minus k, multiply it, it becomes minus or plus 2 pi n by a. So that is equation number 25. Now see, for upper sign, what happens? That is, if you consider plus and minus here, so 2 pi n by a is equal to k minus k, 0. That means for upper sign you are getting n is equal to 0. For upper sign n is equal to 0. Now what happens to for lower sign? For lower sign, see, that is minus and plus. So this k comes to left hand side, plus k, 2k, 2 get cancelled. That means k is equal to pi n by a, you are getting. So that is equation number 26. What is n? N is an integer. N can take both positive and negative values. That means what? It indicates the band edge points. That means what? When you are considering to this is the band, this is the center, this plus n correspond to this edge, this minus n represent the bottom edge of the band. Therefore, roughly here you are getting an idea about the formation of a band. That means upper edge and lower edge limits now we are getting from this study. So therefore, Now what we will do from this? So now you can consider the equation number 16. See, as you know, kn square, here we have taken kn square is equal to k square, right? So in equation number 16, that is Bn is equal to B naught Cn divided by Kn square minus K square. This quantity becomes very large quantity, right? So when Kn square is approximately equal to K square, so what happens? The denominator approaches towards 0. So when it approaches towards 0, then Bn becomes a very large quantity. It becomes very large quantity. Right. So that means what? When you are considering to this, what if it becomes very large quantity, gamma into Bn, this expression we are observing, right, in equation, this is we are observing in our expressions. So gamma into Bn, since even though the gamma is small, Bn is extremely large quantity, gamma into Bn is also a large quantity. This is also a large quantity. Okay. So now what happens? Now the equation number 17. So when you are considering to the equation number 17, so just I will write the equation number 17. Xi of x is equal to b naught e to the power I k x into 1 minus gamma sigma n not equal to 0 Cn divided by k square minus kn square into e to the power minus 2 pi inx by e. This is the equation number 17. Just recall it. Okay. So what happens here? See, when you consider this, so I can write this one as b naught into e to the power ikx into 1 minus gamma, right? Here, see, this is nothing but, you can write this one as plus gamma into Cn sigma Cn divided by Kn square minus K square into e to the power minus 2 pi inx by a. Okay. So therefore here what happens? This becomes, I am multiplying inside b naught into e to the power ikx plus gamma into, what is this? This is nothing but Bn, right? So therefore it becomes nothing but, it is Bn into e to the power. So you are getting k e to the power ikx, you have to multiply here also, it becomes e to the power I into k minus 2 pi n by a of x. This is nothing but kn. I can write this one as knx. So what you are observing here, the wave function is composed of two terms, right? See, one, this is the electron when it behaves like a free particle. So it is not perturbed by any potential when it is moving inside the metal, right? This is the second. This is the effect of perturbation. So that means what? Here you are getting one electron is a material particle. Therefore what happens? It is behaves like a matter wave. Therefore one is represent the forward moving wave Another one is added which is moving in the reverse direction. That means one electron moves like this as a wave, another electron already moved and it hits the upper edge or lower edge and bounces back. That is moving in the reverse direction. So one is moving like this, another is moving in the reverse direction. That forms a stationary wave. Therefore, xi of x is equal to b naught into e to the power ikx plus gamma into bn e to the power iknx. That represents the formation of a stationary wave inside the band. We will continue our discussion in next video lecture.